Okay. So in order to find the dy by dx, we should start with dx by dy because it's x in terms of y. Okay. Tangent function differentiation is secant square. So we will write 3 secant square y minus pi by 6 times the differentiation of the angle, which is just 1. So that's it for the differentiation. Now you can see they don't want any secant and any trigonometric function. We need to achieve just x in terms of x and letters. So we need to get rid of this secant square. Okay. We can use identity. Okay. 1 plus tan square x is equal to secant square x. So we are going to replace secant square y minus pi by 6 as 1 plus tan square of y minus pi by 6. 3 into tan square. Okay. Now from here we need to get rid of tangent. You can get rid of tangent by using this x expression. You can make tangent x the subject, tangent of this angle the subject. That means x by 3 is equal to tangent of y minus pi by 6. So you can replace here 1 plus h square. So you will say x plus x over 3 whole square. From there, okay, whole square. Now we are almost there to the near to the answer. Just simplification. 1 plus x square over 9. You can simplify this expression. 9 plus x square over 3. Take the LCM, etc. Then this is dx by dy. So dy by dx is the reciprocal of dx by dy. So 3 over 9 plus x square. That what we were supposed to write. A over x square plus b. So 3 over 9 x square plus 9. Okay. No questions. Moving on. We have found that dy by dx. The point P with y coordinate pi by 3 lies on C. So this is the value of y. We can find x also using x is equal to 3 tan of y minus pi by 6. We are going to put y is equal to pi by 3 here. Y at what's this point? Q. Sorry, not y. X at Q is equal to 3 tan of pi by 3 minus pi by 6. It's pi by 6 given here, right? No, y coordinate is pi by 3. Yeah, so we put pi by 3 minus pi by 6. So you can get the x coordinate as, okay, let's do it in a little steps. 3 tan of pi by 6, okay, which is 30 degree. So what is tangent of 30 degree? 1 over under root 3. So 3 times 1 over root 3. 3 over root 3. If you rationalize by multiplying up and down with root 3, it is going to become root 3. It's the same thing. I hope no doubt is here. So we have the q coordinates x as root 3 Okay, and y is given as pi by 3. Given that tangent to the C at P crosses the x-axis at Q. Okay, okay, we need to find the coordinates of Q. This was P actually, little change of letter name only. Let's just make it P here. This is P. Okay, so tangent at P, that means dy by dx at root 3. We already have the expression dy by dx 3 over x square plus 9. Put root 3 here, it will be 3 over 12 or 1 over 4. Okay, so equation of tangent at Q, y minus y1 is equal to m into x minus x1. Y minus y1, which is tangent at P, right? Tangent to C at P. So y is pi by 3. We are using the coordinates of P here. Y minus pi by 3 is equal to m. M is 1 by 4, the gradient, into x minus root 3, the P coordinates, root 3. Alright, so this is the equation of the tangent at P, and Q is the point where this P meets the x-axis. So at x-axis, y is equal to 0. So you can substitute 0 here. 0 minus pi by 3 is equal to 1 by 4 into x minus root 3. X is equal to, this 4 will multiply, will go there. Minus 4 pi by 3 plus root 3. Okay, so that's the x coordinate of Q. That's it for this question. Any doubt, any confusion, you can ask me.
No, sir, it's clear.
All right, let's move on. Next is integration. Okay, this has multiple methods. Okay, but let's look at the most conceptually easy, elegant method. First step, you have to expand like a minus b whole square, a square plus b square minus 2ab. Okay, so this is 4 cosine square x plus sine square x minus 4 sine x cosine x, so that we can individually integrate them. Okay, well, you know that sine square x plus cosine square x is 1, that identity. So I'm going to deduct 1 cosine square x from here. I'm going to write it as 3 cosine square x. 1 cosine square x plus 1 sine square x, that made a 1 here. Okay, the rest is same so far. Our aim is to convert this into double angle. I want to convert this into double angle and this expression into double angle, because it's easy to integrate single angles, which don't have square terms, etc. So now we can substitute for cosine square x the double angle formula, this one. Okay, cosine square x is cosine 2x plus 1 divided by 2. All right, that means 3 and what to do with this term now? This we can use 2 sine x cosine x is equal to sine 2x. The first one, 2 sine x cosine x is sine 2x. So we can break minus 4 into minus 2 times 2 sine x cosine x. Okay. In this step, we can also start simplifying this also. 3 cosine 2x over 2
Sir, wouldn't it
plus,
just be minus two sine 2x?
yeah, I am going to do that in this step.
Okay.
Just for a clear elaboration, I didn't do it there. So 3 by 2, you are right. 3 by 2 plus 1 plus 2. Yeah, here you can write minus 2 sine of 2x. Now we can start the integration. Obviously, you can do that faster. So this will be 3 by 2 sine 2x and divide by the derivative of the angle also, which is 2. 3 by 2 plus 1 is 5 by 2. So differentiation integration of that will be 5 by 2 x. Okay. And this is, I'm sure you know, sine 2x is minus cosine 2x integration. That minus will multiply with this minus to make it plus 2 cosine 2x. But you need to divide by the derivative of the angle, which is 2. So this 2 will cancel with 2. We can erase this and write directly the final answer. Okay. Plus c. Sorry, not final answer. This also we can make it better looking. It can be 3 over 4. So we can write it properly here. 3 over 4 sine 2x plus 5 over 2x plus cosine 2x plus c. That's it for 5 marks. There are other methods, other possible scenarios also, but I think this is the conceptually best to use the double angles. They look like double angles, so it's best. This is also now differentiation question and also iteration combined. Is it the last two question? No, we have question 10 also. That is a logarithm, I think. Okay, we can skip that. Question 9. Okay, we have the curve y is equal to this root 3 plus 4 e raised to power x square. Need to differentiate this first. Okay, so this will be straightforward part. Any square root, it comes down 1 by 2 times subtract the power. So first you can simply bring it down. 3 plus 4 e raised to power x square. Multiply by the differentiation of the inside, whatever is inside. So it's a exponential function. It will be written as it is. Power is a little funny here. E raised to power x square times the differentiation of the power. So x square differentiation is 2x. 4 2s are 8. 8 divided by 2, 4. X e raised to power x square divided by root of 3 plus 4 e raised to power x square. The marking scheme write it as in the numerator, but it doesn't matter if you leave like that also. I think it's better to leave like that. All right, no questions here.
Sir, I have a question.
Yes.
What if I wrote y equal to 3 plus 4 e to the power x square to the power of a half?
Yeah, that's fine. That's totally fine. You can do that.
Can you solve it that way too?
Yeah, sure, sure. Uh, it's never discouraged that way if you are not too fast or sure about directly doing it. Oh, sorry, it has to be that way. 1 by 2. So dy by dx, bring the power down, 1 by 2, 3 plus 4 e raised to power x square. Subtract 1 from the power, so minus 1 by 2. Multiply by the same, the differentiation of the bracket, which is 4 e raised to power x square times 2x. Again, 4 to the 8, 8 divided by 2, 4, x, this x, e raised to power x square. And this is just like the root, but you can leave it like that also if you want. 3 plus 4 e raised to power x square raised to power minus 1 by 2. This is same as it is, same thing. All right, got it?
Yes, sir.
Yeah. Let's move on. Oh, we have B part now, sorry, long question. B part, you can see that the tangent to this curve at P passes through origin. Okay, so, and this value is alpha, x coordinate is alpha. Show that it is a solution of this equation. Well, you remember something from our elementary maths that if there is a graph and there are two equations, okay, if you want to find the intersection point, you can equate both of them, right? If this is y is equal to ax, if this is y is equal to bx, in order to find the intersection point, you can do bx is equal to ax. Same thing we have to do here. We will find the tangent equation and then we will equate it to this. That will simplify and become this. Same concept as that one. Okay, first let's start finding the differentiation, I mean the tangent equation of P. So what do we need to find the tangent equation? We need a point. It's already here. Equation of tangent at P. We have a point because it passes through origin. And we have the gradient also. We need the gradient because alpha is just unknown. So gradient is just dy by dx that we just got. Okay. You can imagine just in place of x, we have alpha. Okay. So equation of tangent is y minus y1, which is 0. Y minus 0 is equal to m. The gradient is this one, this function m. I know I'm not placing anything in place of x, but that is just alpha. That is another variable. We don't have value of alpha. M, y is equal to mx, right? So mx plus c. C is 0 because it's passing through origin. So this is the equation of the tangent. You just need to equate it to the curve equation. There is an x also here. So that x is going to make it a square. And this let's equate to the equation of the curve at the start given. 3 plus 4 e raised to power x square root. Okay, simplify that. It's very easy actually from here. This root is going there, so root will cancel. This root cancelled is just 3 plus 4 e raised to power x square. Bring it here and you have got the answer. Okay, minus 4 e raised to power x square minus 3 is equal to 0. This is what they wanted. We got it. Okay, And actually, through this process, through this working, actually the question is just trying to tell us how to use iteration method. Iteration method is like you make some y is equal to mx line, x line, and find the intersection point instead of solving. Anyhow, now this is the equation, and obviously alpha, the root will satisfy this because this is the intersection point. The solution to this equation will be the alpha value, okay, the intersection point. Okay, so if no questions, moving to part C, show that alpha lies between 1 and 2. So if you recall from the iteration method, numerical methods chapter, you need to look for the change in sign. So these are very easy 2 marks. Just put 1 here and then put 2 here and look at the change of sign. The C part, at x is equal to 1, the above equation is -3. You just put 1 here, and at x is equal to 2, the above equation is plus 652. So there is a change in sign. Okay, that means there must be a root lying between 1 and 2. If you look at the marking scheme, it also says that and it is a continuous function. That is just an observation. Continuous function, why they mention? Because sometimes you have stepwise functions. So this method is not applicable to them. If what if the function is just jumping, it's not crossing the x-axis. So it has to be a continuous smooth curve. Only that then we can be sure that there is must be a root. Okay. But that's just an extra point written. No questions. Moving on to D part. So how to get this formula from this equation? If you look carefully, which x is made subject? Obviously there is a e term here, so this is not the x that they made the subject, and it will be very difficult. This is not the x that they made the subject. It is this x that was made the subject. So we will rearrange this equation and just make this x the subject. Okay. D part. First write the same equation again. This is also easy part. So you can take e raised to power x square common and move 3 there. Taking common, it is 4x square. Oh, you can take 4 also common here. So it is just x square minus 1. Yes, is equal to 3. We need to make this x the subject. Okay. We'll keep this x square here. Uh, 3 over, what's happening? Wait a second. Let me double check. Let's continue. Wait a second. For e raised to power x square. And then this one there. Okay. Then you can take the LCM. This will become 3 plus 4 e raised to power x square. Okay. Now there is an x square here, so if you want x, you can take the square root. Still, it's not the final form actually. So how about we take this 4 out, 1 by 4 out. That will become 1 by 2. The square root of 1 by 4 is 1 by 2. So what do we have left? 3 plus 4 ex square over ex square. One last step, give this denominator to each of the term. For the first one, it will become 3 over e raised to power x square, which can be written as 3 e raised to power minus x square, right? The denominator is written. For the second one, it just cancels when you distribute, so it's just 4. Isn't this the form that they wanted as the iteration formula? You can check now. 1 by 2, 4 plus 3 e raised to power, oh sorry, this one, 1 by 2, 4 plus 3 e raised to power minus x square. It was just 1 mark question. Wow. I think I did it a little long way. Yeah, it can be done a little faster also. Wait, if you don't mind, one more time. Uh, you can just move these two terms here. That's what we're supposed to do it fast. 4 x square e raised to power x square is equal to 3 plus 4 e raised to power x square. Then 4 e raised to power x square, you can bring it to the other side. So you have, no, just x square, keep it here. 3 plus 4 e raised to power x square divided by 4 e raised to power x square. Now you can distribute the denominators like we were doing before. It will be, yeah, 1 by 4. You can take the square root. So we get rid of this 4 in the denominator. 1 by 4 square root is 1 by 2. And 3 over e raised to power x square is 3 e raised to power minus x square. And this cancels. This is cancels, just 4 is left. So you can do it in 3 steps. Okay, 1 2 3. This is a little faster way. Here we prolonged it a little bit, but it's not that long. All right, let's move to E part. No questions. Now we just need to use this iteration formula to solve the question. So x1 will be 1, reach until x3 up to 4 decimal place, and then we will continue a little more so that we see if it is repeating itself. That will be alpha. Okay. Okay, first x3 we need to find. Our iteration formula xn plus 1 is equal to xn square, 1 behind. Okay. Uh, with x1 is equal to 1, okay, with the initial value will be x1 is equal to 1. It's not x naught, so we start with x1. So we directly find x2 actually. That's easy. x2, 1 by 2, 3 e raised to power 1 will be just e, 3e plus 4. We need the decimal value using calculator. Up to 4 decimal place. 1.743. 2. Now we can find x3. You can put this back in the formula. x3 I'm getting as 1.0178. All right. Uh, Marking scheme says 1.0997. 0997. It's a little different. One more time, let me check then. Yeah, made a mistake here. This is e raised to power minus 1 when you put 1. So that will be 3 by e. You just need to put a slash here. Divide 3 by e plus 4. Let's edit them again. Okay. So x2 is 1.1296. Now you put back in the formula again. Yeah, now we are getting 1.0997. Okay. Up to 4 decimal place. Okay. But we need to continue this. Continue for few more iterations until it is repeating, right? To find alpha, you need to continue. So let's do it. Let's find x4, 5, 6. I hope by 5 we can reach the repetition. Keep using calculator for that. X4 1.1063. It's like we are working as a program. We just keep repeating. I think this is the second last. We can reach the solution now. 1.1048. One last x6. Maybe two more. Yeah, that repeated. We are getting the same for x6 and x7 up to 4 decimal places. Okay. So alpha is 1.1051 up to 4 decimal places. Okay. That's it for question 9.